Hey friends, welcome to the YouTube channel All About Electronics. So in this question, we have been given this circuit and as you can see, it consists of the switch and the capacitor. So here, the sinusoidal signal is applied to the given circuit and here we have been given that the output of this circuit is given to the ADC. So for this ADC, the input impedance consists of the 10 megohm resistor in parallel with the 0.1 microfarad capacitor. So in the question, we have been given that in this circuit, at time t is equal to 0.5 second, the switch is opened and after that, here we have been asked to find the output Vx at time t is equal to 1.5 second. So let us find that. So here we have been given that in this circuit, this output Vx is given to the ADC. And if we see the input impedance of this ADC, then it can be represented as this 10 megohm resistor in parallel with 0.1 microfarad capacitor. So equivalently, this is how the circuit will look like. Now here, if we see this switch and the capacitor, then it is nothing but the sample and hold circuit. So here, whenever the switch is closed, then the sample and hold is in the sample mode and the voltage across this capacitor is same as the input signal. And whenever the switch gets opened, then whatever voltage that is appearing across the capacitor will be applied to the ADC. So that will be the hold mode. And during this period, this ADC can take the reading. But anyway, here we have been asked to find the output of the given circuit at time t is equal to 1.5 second. So here, for us, this is nothing but the basically a RC circuit. And here if you see, then these two capacitors are connected in the parallel connection. So their equivalent capacitance will be equal to 0.1 microfarad plus 0.1 microfarad, that is equal to 0.2 microfarad. So here, when the switch gets opened at the 0.5 second, at that time, the voltage across this capacitor will discharge through this resistor. So here, we've been asked to find the voltage across the capacitor or this voltage Vx at time t is equal to 1.5 second. But for that, first of all, we need to find the initial voltage across the capacitor. That means the voltage across the capacitor at time t is equal to 0.5 second. So here, we've been given that the input to this circuit is nothing but the sinusoidal signal, that is equal to phi sine of pi t by 3. So here, let's see the value of the sinusoidal signal at time t is equal to 0.5 second. So in this equation, if we put the value of t as 1 by 2, then the value of the Vm will be equal to phi sine this pi by 3 times 1 by 2, or that is equal to phi sine pi by 6. So we know that the sine pi by 6 or the sine 30 is equal to 1 by 2. That means the value of the Vm is equal to 2.5. So we can say that at time t is equal to 0.5 second, the value of the sinusoidal signal is equal to 2.5 volt. It means that at time t is equal to 0.5 second, when the switch is opened, at that time, the voltage across the capacitor is equal to 2.5 volt. And if we see the equivalent circuit, then it will look like this. So here, now the voltage across the capacitor is equal to 2.5 volt. And now, the charge across the capacitor will discharge through this resistor. So we know that when the capacitor is discharging, then the voltage across the capacitor or this Vc of t can be given as V0 times e to the power minus t divided by Rc. And here, this voltage is same as the Vx. But here, in this case, let's say this t is equal to t dash, where this t dash is equal to t minus 0.5 second. Because here, this is the equivalent circuit at time t is equal to 0.5 second. That means now, our reference will be equal to 0.5 second. And here, the value of the V0 is equal to 2.5 volt. So we can say that here this voltage Vx is equal to 2.5 times e to the power minus t dash divided by Rc. And here this R is equal to 10 mega ohm and the C is equal to zero point 0.2 microfarad. It means that this RC is equal to 2 seconds. So from this we can say that here this Vx is equal to 2.5 times e to the power minus t dash divided by 2. So here we have been asked to find the value of the Vx at time t is equal to 1.5 second, or equivalently if we see the t dash, then that is equal to 1.5 minus 0.5 second, that is equal to 1 second. So we can say that this Vx is equal to 2.5 times e to the power minus 1 by 2. And if we calculate the value, then that is roughly equal to 1.516 volt. So we can say that at time t is equal to 1.5 second, the voltage at this node Vx is equal to 1.516 volt. And therefore, for the given question, the answer is equal to 1.516 volt.